Exercise 6-2, and I've done 6-1 and 6-3 are very similar, and actually I've done both of those to kind of show you what we're doing, but it gives us the information. It says compute the mean and the variance of the following discrete probability distribution. So in this case it gives us some pretty simple numbers, 0, 1, 2, and 3. And the probability of those numbers is apparently 20, 40, 30, and 10, which should add up to 1 or 100%, we could call that. Okay. And so then we take and we apply, what we want to do is apply our probability, okay, to the number, whatever that happens to be. Okay, over here, and it doesn't give us any information about what this is, but we simply, in order to compute the mean, that's what we're going to find out here, is apply the probability. So by apply I mean multiply it. So it's just, this is equal to, or I'm sorry, this is equal to that number times my probability. Hit enter, and then that formula is going to stay consistent all the way down, and so I can do that. Okay, and then to find the mean, okay, I simply have to sum that. Okay, and there we go. The mean is 1.3, and that means that when we apply these probabilities, the 20, 40, 30, 10, to these numbers, the mean of these numbers based on those probabilities comes out to be 1.3. And then, like we learned in some prior chapters, kind of when we were figuring standard deviation, we always get variance first, right? So we walk through that exercise, which is just subtracting our number from the mean. Okay, so this is equal to our number here, okay, minus the mean that we came up with, and I'm going to hit my F4 button because then I'll be able to just copy and paste this, right? Okay, and that gives me a column of numbers that's only useful then in continuing on, I should say. Okay, and so now I need to square that like we always do, and that's equal to, really just gets rid of the negative sign. My little hat thing to the second power, I square that. That I can also drag down. Okay, now I apply my probabilities. Okay, again, this was the mean of the numbers with probabilities. Now I apply my probabilities again, okay, to wind up with a variance, and ultimately I could wind up with a standard deviation if I wanted to. But by applying the probabilities again, I'm just saying that this is equal to my number. Oh, I'm sorry. My probability, gosh, I said the wrong thing there, times my result here. Okay. There we go. And then I just carry that down. Okay. Again, this was my probability times the result that I came up with here. Right? Okay. And then to get my variance, in this case, all I have to do is sum those numbers. There we go, 0.81. If I was to figure my standard deviation, it would actually be higher, I believe, than my variance. Wouldn't my standard deviation be 0.9? I think so. Interesting. Okay.